Okay, so we are given 4 lines here. For each one of these lines, we have to find its x and y intercept and then use that information to graph the line. So we can do 4 of them together. So let us write a combined solution. The x-intercept of the line three x plus 4y equal to 12 is the x coordinate of the point where the line crosses the x-axis. If this point is okay, so we know what x-intercept is. So it is the x coordinate of the point where the line crosses the x-axis. So the y coordinate will be 0 because we are on the x-axis. So if the point is say x0, 0, then due to the fact that this is a point on this line, the coordinates will satisfy the equation and we will get 3x0 plus 4 times 0 equal to 12, which implies x0 is equal to 4. Just like that, the y-intercept of the line is the y coordinate of the point where it crosses the y-axis. On the y-axis, any point will have its x coordinate equal to 0. So if this point is 0, y0, then 3 times 0 plus 4 y0 equal to 12, which implies y0 is equal to 3. So the x coordinate is 4 and the y coordinate is 3. Okay, now let's draw the graph for this one, and for the other ones also we will draw it in this same coordinate plane. For the other exercises we are not going to write this much. Okay, so this is our x-axis, this is our y-axis, and then let's put the numbers also. Say 1, 2, 3, 4, 5, -1, -2, -3, -4, and so on. 1, 2, 3, 4, 5, etc. -1, -2, -3, -4. This place is a little, it looks a little cluttered, but you can understand what we are trying to say here. Okay, so the line we have now has x-intercept 4 and y-intercept 3. So that means this is the point where the line will cross the x-axis, and this is the point where it will cross the y-axis. So the line will look like this. So just like that, what about this one? So the others we are going to just simply find the intercepts and then draw the line. So for the exercise 32, the equation is this. So for the x-intercept, we have to put y equal to 0. That's what we understand from these arguments. So we have to put y equal to 0. So that means the x-intercept is -4. And what about the y-intercept? For that we have to put x equal to 0. So y will be -2. So x is -4 and y is -2. So this is the point where the line will cross the x-axis, and this is the point where it will cross the y-axis. You can, if you are not really sure about this thing, you can put the coordinates of this point here. If you say put x equal to -4 and y equal to 0, you see that the equation is satisfied. Similarly, if you put x equal to 0 and y equal to -2, then the equation is satisfied. So yes, that is the line. Okay, then 33. Square root of x minus square root of 2 times x minus square root of 3 times y is equal to square root of 6. For this line, the x-intercept, you put y equal to 0, and the x-intercept has to be square root of 3, and putting x equal to 0, the y-intercept has to be minus square root of 2. Okay, so now of course we can, we will have to draw the line and locate the points somewhat approximately, because these are irrational numbers. Square root of 2 is approximately 1.41 for something, okay, 213, etc. So minus square root of 2 will lie here somewhere, a little below minus 1 and above minus 2. So that is the y-intercept. So the line will cross the y-axis at this point, and the x-intercept is square root of 3. Now if we take 3 square, okay, is it also lying between 1 and 2? Yes, it is. It also lies between 1 and 2, although the value will be somewhat different. I don't remember the value exactly. It's 1 point something, that is for sure. So it will lie here somewhere. And this line is like this. And finally, this one. For this we have to do the calculations here. Minus 3. So if for x-intercept we have to put y equal to 0. Fine. So that means it will be minus 3. 1.5 is 3 divided by 2. So dividing by 1.5 is equivalent to multiplying by 2 divided by 3. So that means this is minus 2. And y-intercept is obtained by putting x equal to 0. That is 3. Okay, so here x-intercept is minus 2 and y-intercept is 3. So this is the line. So this is 31, 32, 33, and this is 34. Okay, so these are the graphs of the equations. That way also we can interpret. So that is the solution. I hope I have not made a mistake anywhere. Let me just quickly see the things. The x-intercept of this is the x-coordinate of the point where the line crosses the x-axis. So on the x-axis, any point has y-coordinate equal to 0, fine. So the point will look like this. So then of course it has to satisfy the equation. From there we are getting it's not equal to 4. And y-intercept, fine. So the idea, there is no problem with the concept. And what about the calculations? 3, 4, fine. Okay. So let's move on. The next one is 35. Now for the previous 4 I should have written exercise 31 and so on, but okay, anyway. Is there anything special about the relationship between these two lines? Is there anything special about the relationship between the lines ax plus by equal to c1 and bx minus ay equal to c2, where both a and b are non-zero. Question mark. Give reasons for your answer. The given lines can be written means their equations can be written. Often when we will be talking about line, we will not distinguish between the line as a geometric object and its equation, which is an algebraic object. So we may simply say between the lines like this, as if this itself is the line. Strictly speaking, it's not the line, but it's an algebraic equation which represents the geometric line, but we are not going to make that distinction. The given lines can be written as this. Say the first one, that is, the equation can be rearranged like this: minus a divided by b times x plus c1 divided by b, and the second one, b divided by a times x minus c2 divided by a. Note that we have been able to divide by b and a because it's given that both of them are non-zero. Now these are lines of the form y equal to mx plus c. So the corresponding slopes or the respective slopes are, we can just read off the slopes from these two equations because they are in that form, y equal to mx plus c, where m should be the slope. So the first one has slope minus a divided by b, and the second one has slope b divided by a. Since minus a divided by b times b divided by a is equal to minus 1, the given lines are perpendicular. Perpendicular to each other. That is the relationship between them. Just give me a moment. Okay. then 36. Another similar one, is there anything special about the relationship? Between the lines ax plus by equal to c1 and ax plus by equal to c2, where again both a and b are non-zero. Give reasons for your answer. Here also we will just simply find the slopes and then see how the slopes are related. The given lines can be, or we can just simply write like this, the given lines are, this language does look a bit weird. The given lines can be written as, usually it's not written like this. Rather, one would write the equations of the given lines can be rewritten as or rearranged like this. Anyway, so we can write like this also. The given lines are y equal to minus a divided by b times x plus c1 divided by b, and y equal to again minus a divided by b times x, but this time plus c2 divided by b. The corresponding slopes are, or the respective, same thing, the respective slopes are both minus a divided by b. So they have the same slope. Hence, the given lines are parallel. So that is the relationship between them. Okay, next we come to some exercises based on increments and motion. We have already seen exercises. In fact, we started this set of exercises with some exercises on increments and distance, but this time we are going to see increments and motion. Exercise 37. A particle starts at this point. Starts at A minus 2, 3 and its coordinates change by the increments delta x equal to 5 and delta y equal to minus 6. Find its new position. Okay, so let's start the solution like this. Let the coordinates of the new position of the particle be x naught, y naught. Then delta x, which is given to be 5, is x naught minus the old x coordinate, that is minus 2, and the y increment, which is minus 6, is new y coordinate, which is y naught minus old y coordinate, that is 3. From these, what do we get? X naught will be 5 minus 2, so x naught is 3 and y naught is minus 3. So the particle will be at the point whose coordinates are 3, minus 3. Exercise 38. Another one of similar type. A particle starts at the point A 6, 0. Yeah. And its coordinates change by the increments. This time delta x is minus 6 and delta y is 0, find its new position. So this time we can write the solution more sketchily, not writing all the things, just writing whatever we are going to calculate. So let the new position be, of course this is not how the solution should be written, but it's just for the sake of showing what is to be done. Then minus 6 is delta x, which is new x coordinate minus old x coordinate, and 0 is delta y, which is new y coordinate minus old y coordinate, which is 0. From these two things we get x naught equal to 0 and y naught also equal to 0. So the particle after making this journey, it comes back to the origin. I should not say comes back, but it comes to the origin, which you can just, instead of going through these calculations mechanically, you can also try to understand it somewhat casually. The particle starts at the point which is here. Or no, sorry, not here but here. 6, 0, where this point is 6 units away from the origin. Delta x is minus 6, so it will shift towards the left hand side of the x-axis and by 6 units, so it will come here, and delta y is 0, so along the y-axis there is no motion, so that's why it comes to the origin. That way also you can think. Then 39. The coordinates of a particle change by delta x equal to 5 and delta y equal to 6 as it moves from this point ax comma y to b3 comma minus 3. Find x and y. So we just do the calculation to find x and y. Delta x is 5. So the journey was made from A to B. The starting and ending points matter. Okay. Which one is the starting point and which one is the ending point, that matters. So it starts from here. So delta x by definition is 3 minus x, final x coordinate minus initial x coordinate. Like that, delta y, which is given to be 6, is minus 3 minus y, and these equations give us x equal to minus 2 and y equal to 3. No, sorry, not 3, minus 9. y equal to minus, yes, y equal to minus 9. So the particle started its journey at the point whose x coordinate is minus 2 and y coordinate is minus 9. Finally, another one of this type of exercises, 40. A particle started at A1, 0. Circled the origin once counterclockwise. Okay. And returned to that same point, A 1, 0. What were the net changes in its coordinates? This exercise again brings back that one point that we talked about while discussing about increments, that the increment of in the x and y coordinates of a particle's position depend only on the initial and final position and not how the particle makes the journey from one point to another point. So here what is happening is this. This is the point A 1, 0. The particle starts here and circles the origin once and comes back to this. Okay, it could have made this journey in any other way, but the particle has chosen to follow a circular path. What were the net changes in its coordinate? No net change, because the coordinates of the initial point and the final point are the same, because the points themselves are the same. So both the increments are equal to 0. We can simply write like this: since the starting and the ending points of the particle's journey are both this. There is no net change in its coordinates, that is delta x is 0 and delta y is also 0. Now after this we come to some applications of these ideas. And in applications there are exercises 41 and 42 which are about insulating a house from cold weather in cold countries where the climate is usually cold. Only in the summer it's somewhat pleasant. So there houses have to be insulated using different kinds of insulating material. Say the inner part of the house, I mean the actual wall of the house, just outside of that wall there will be some material, then outside of that there will be something else, wood panels, insulating materials which will help keeping the cold outside, or more exactly speaking, it will help keeping the heat inside. So a figure is given in the book where that one particular type of insulation is given, and how the temperature drops as we go outside through the insulation, that is also given. We are being asked to find the best insulating material depending on how less rapidly the temperature decreases as one goes from the inside of that material towards the outside surface, okay, based on the given data. That I am leaving out, I am not going to do it. One reason is that it's quite straightforward to find the slope. I mean, a curve like this is given where this is the temperature and this is the actual insulation, different layers of the insulation. So based on how the curve is dipping, of course when we go outside from inside through these insulating materials, the temperature is going to drop because the climate outside is cold, the weather outside is cold. So the curve will go down, but it will go down through that insulating material at different rates. That rate can be calculated by finding the slope of the curve inside that material, inside one of the insulating materials. If the slope is too much, then it's not a good insulator because it cannot keep heat inside. But if the slope is really very low, if the temperature does not significantly change between the inner surface and the outer surface of that material, then it's a good insulator. So that can be calculated. And one other thing is that it is somewhat very difficult to draw the exact thing here. So I urge you to go through that exercise yourself, find the slopes and try to match that with whatever answer that is already given at the back of the book. So I am leaving these two things out. So from 43, from the 43rd exercise we are going to go. Pressure under water. The pressure P experienced by a diver underwater is related to the diver's depth. D by an equation of the form P equal to Kd plus 1, where K is a constant. You can see that the equation is a linear equation in P and D, and that's why it is here in this set of exercises. And it's common knowledge that as we go down deeper and deeper into a body of water, the pressure keeps on increasing. Okay, now something else is given, some numerical data. At the surface, the pressure is 1 atmosphere. 1 atmosphere means the pressure experienced by us due to the atmosphere we have above us, that is 1 atmosphere in ordinary conditions. The pressure is at 100 meters is about 10.94. Okay, that's a lot. Atmospheres. Find the pressure at 50 meters. So what would the pressure be at half the depth? I think 100 meters, I'm not sure, but 100 meters is the limit, or maybe 200 meters is the limit of recreational diving, after which it becomes really dangerous and specialized breathing equipment is needed and training is also needed. There only professionals go, professional divers, scuba divers. I myself, I don't know swimming, and also I am very afraid of water, especially deep and dark water. I have that thing called thalassophobia. Anyway, let's solve this exercise. Okay, so it's about a linear equation. Ultimately, it comes down to this. Since the pressure is 1 atmosphere, at the surface we have, so at the surface the depth is 0 meters, so D is 0 and P is 1. Oh, so that actually does not give us anything, no? If we put P equal to 1 and D equal to 0, we just get an identity, 1 equal to 1. So this does not help us. This part will help us. At 100 meters it's about 10.94, atmosphere. So let's just write that 10.94 atmospheres at a depth of 100 meters. So we have (10.94) equal to 100K plus 1. From this equation we can solve for K and find the value of K, which implies K is equal to, okay, so this will be 9.94 divided by 100, that is 0.0994. Okay, so what is the pressure at 50 meters? Now the pressure at a depth of 50 meters is, so now we can use this value of K times 50 plus 1. Okay, so we can calculate it mentally now. And then we have, okay, so basically what we have done here is we are multiplying 994 by 50. That gives us this. Let me once again check, since I am you already know my calculations are very bad. Okay, divided by 4 plus 1, so that means this is 4.97 plus 1, this is equal to 5.97 atmospheres. (10.94). Okay, then exercise. So all these applications are in one way or another related to linear equations and straight lines. A ray of light comes in along the line x plus y equal to 1. From the second quadrant there is a figure. From the second quadrant and reflects off the x-axis. The angle of incidence, so these are terms from optics. It's shown in the figure that we will draw now, but if you recall your lessons from optics in physics, there you have these things: angle of incidence, angle of reflection, and you have this law also that if you have a reflective surface that is plane, then the angle of incidence should be the same as the angle of reflection. So that principle they are going to use here. The angle of incidence is equal to the angle of reflection. Write an equation for the line along which the departing light travels. And this is the figure. Before I draw the figure, I think it will be better to put some ink in this. The figure is nothing much. It just shows how the light ray has come in and how it's reflected off the x-axis and how it goes out. Okay, so along this line the ray is coming, it's reflected and it's going like this. This is the line x plus y equal to 1. So that means its y-intercept is 1 and x-intercept is also 1, because both the points 1, 0 and 0, 1 are on this line. This is the origin, this is the x-axis and this is the y-axis. This is the angle of incidence. Angle of incidence. This is the angle of reflection. They have I think point, okay, yes, the angles are measured using rotation. We have to find the equation of this line. Okay, so the slope of the line x plus y equal to 1 is 1. This means oh sorry, what the hell have I written? The slope is not 1, the slope is minus 1. Yes, because y is equal to minus x plus 1. Okay, so the slope of this is minus 1. So what does it mean? It means, this means the angle made by x plus y equal to 1 with the y-axis is 45 degrees. Angle made with the y, oh, but we should be specific in which angle, no? We cannot just simply say like this. The smaller angle, because there is inclination is there, that is the angle made with the positive direction of the x-axis. That is this angle, which is 90 degree plus 45 degree. Because it has to be minus 1. However, what we, okay, so we can in fact say like that also. Instead of writing like this, which is somewhat confusing, the angle made by x plus y with the positive x-axis is thus the angle of incidence. From this it follows that the angle of incidence is 45 degree. So the angle of reflection is also 45 degree, this one, and that is why the inclination of this line must be this, which of course is this, with that is also 45 degree. 90 minus the angle of reflection. Thus the line along which the departing ray or departing light travels makes an angle 45 degree with the positive x-axis, that is this angle. So the slope of this line is, this one will have slope 1, since this line passes through this point 1, 0, its equation is y minus 0 equal to slope 1 times x minus 1, that is y equal to x minus 1. So along this line the departing ray will travel. So this is the equation of the line, and from the equations you can see that these two lines have to be perpendicular to each other, which you can also see from geometry. Then 45 Fahrenheit versus Celsius, and then two more applications are there. After that we have other exercises. So let's do these two applications in the next video along with other exercises. So I end the video here itself. If you have any doubt or any queries regarding this thing or anything else related to mathematics, you are encouraged to write in the comment section below. So that will be all. Until the next video, this is me, Lucifer, from a mathematical room. Have a nice day.